This algorithm detects edges in a grayscale image by measuring how quickly pixel intensities change between adjacent points. It works by examining each pixel and its neighbors to calculate a gradient magnitude, which represents the strength of intensity change. The input is a grayscale image where each pixel has a value from 0 black to 255 white, and the output is a binary image where pixels are either 0 non-edge or 255 edge based on a threshold value. Before we get into details, please read prerequisite knowledge in the description. They are absolutely crucial for understanding the algorithm. The method uses two simple difference calculations between diagonally adjacent pixels. For each pixel position, it compares the current pixel with its bottom right neighbor to calculate one gradient component, and compares the right pixel with its bottom neighbor to calculate another component. These two measurements capture intensity changes in diagonal directions. The absolute values of these differences are combined into a single magnitude value that indicates how much the intensity changes at that point. This magnitude is then compared against a threshold. If the change is strong enough, the pixel is classified as an edge and set to white, otherwise it remains black. Now let's break down the code. The interface consists of a header with controls, checkbox and threshold slider, and a figure element containing the original image and the canvas overlay. CSS uses flexbox to maintain layout proportions and object fit contain to preserve the image aspect ratio. The function convert to grayscale converts an image object to grayscale by iterating through its pixel data. For each pixel's RGB values, it calculates a perceptual luminance value using the formula, then sets all color channels to this value, preserving the alpha channel. The operation modifies the ImageData array in place. The function Roberts edge detection implements the Roberts cross operator for edge detection. It creates a new uint8 clumped array to preserve the original data. For each pixel, it calculates horizontal and vertical gradients by comparing diagonal neighbors, current diagonal and right bottom. The gradient magnitude is the sum of absolute differences, which is thresholded against this threshold to produce a binary edge map. The result is returned as a new ImageData object. The event handle input manages user interactions. It reads the checkbox state and slider value, updating the global sys settings and threshold display. It clears the canvas and either displays the original image or triggers edge detection and displays the result based on the user's threshold parameter. The setup calculates the scale dimensions and position to maintain the image aspect ratio similar to object fit contain. It draws the image onto the canvas, extracts its pixel data, converts it to grayscale, and stores for processing. The initial edge detection is triggered by calling handle input. The algorithm effectively highlights areas of rapid intensity change that corresponds to edges in the image. Its simplicity comes from using only 4 pixels for each calculation and requiring only basic arithmetic operations. The threshold parameter controls sensitivity. Lower values detect more subtle edges, while higher values only show the most prominent boundaries. This provides a straightforward way to isolate important structural information from the image, while ignoring gradual shading variations. The code is heavily commented, so you can examine it at your own pace. The link to the file location is in the description. Let's scan the code. That's all from my side. Be well.